In this module, we'll be talking about different types of events. The first type of events are called mutually exclusive events. If we take two events, let's say A and B, these two events are said to be mutually exclusive if these two events cannot occur at the same time, and they do not have any common outcome. Such events are called mutually exclusive event. Let's say, for the joint occurrence of event A and B, the probability of A and B is equals to 0. It's visible from this Venn diagram that there is no overlapping between an event A and event B. A random experiment consists in observing the gender of two randomly selected individuals. The event A says that both individuals selected are male, whereas an event B says that the both individuals are female. Here, event A and B are mutually exclusive events, because if both are males, then both cannot be female, and a person cannot be a male and female at the same time. That means that probability for being a male and being a female is 0. Hence, the event A, that is, both individuals are male, and event B, that is, both individuals are female, are mutually exclusive events. The other type of event is equally likely event. These are the two events, or more events, that has the equal probability of their occurrence. Like when we toss a fair coin, the probability for the occurrence of a head is 1 by 2, and the probability for the occurrence of a tail is also 1 by 2. And these are the all possible outcomes from this experiment. In this random experiment, since the probability of the head and probability of the tail is the same, that is equals to 1 by 2, these two events are going to be called as equally likely event. Similarly, when we roll a dice, in that experiment of rolling a die, the possibilities could be that the outcome will be 1, the outcome could be 2, the outcome could be 3, 4, 5, or 6. For all these different events, the probability of occurring 1 is 1 by 6. The probability for the occurrence of 2 is 1 by 6. And likewise, the probability for all the rest of the events, it's going to be 1 by 6. So, while in an experiment of a rolling of a die, all these events are also equally likely events. The other type of event is called collectively exhaustive events. Two or more events are said to be collectively exhaustive when union of the mutually exclusive events make the entire sample space. Like when we toss a fair coin, our sample space is head and tail. Both the events for the occurrence of head or tail may not occur together. Hence, they are mutually exclusive. And the union of both events makes the entire sample space. That is, the head occur or a tail occur. And if we take them together as the union, it's going to make a whole sample space. Such events are called collectively exhaustive events. Then there are dependent and independent events. Dependent events are those when we take two events, A and B, and the occurrence of event A is heavily dependent upon the occurrence of event B, or vice versa. It is denoted by probability of A and B, which is given as probability of A with the product of probability of B given A. So the event of being a diabetic and having a family history of diabetes are two dependent events. So if we say that being a diabetic is an event A, and having a history of diabetes is an event A, and having history and being a diabetic is an event B, then probability of being diabetic and having history of diabetes is equals to probability of being diabetic with the product, probability with the history of diabetic with the product of being diabetic, given that there is already a history of being diabetic. Two events are said to be independent events if the occurrence of one event has no impact upon the occurrence of another event, as it is given in this example, that having 10 letters in your last name and being in biological sciences major are entirely independent events. They do not have any impact, whatever your name is. Many times it's not obvious whether two events are independent or not. In such situations, we use the following formula. And this formula is true if two events A and B are independent. Then comes the complementary events. To every event A, there corresponds another event that's a complement. The word not is used sometimes to describe the complement of an event. Since the event, its complement must account for all the outcome of an experiment, their probabilities must add up to 1. And we can see it from the equations and the Venn diagram as well. That if we say in a sample space, this pink circle represents an event A, then the rest of the blue area in this sample space is called the complement of an event, which means if this is event A, this all blue area is not an event A. And if we join both, it makes up the whole sample space, and their probability is gonna be equals to 1. Let's take an example for the complementary events. That if we know that approximately 2% of the Pakistani population is diabetic, then the probability that a randomly chosen Pakistani is non-diabetic is 0.98. Let's take that A is an event that a Pakistani is diabetic. The probability of A is gonna be equals to 0.02. And the probability of its complement is 1 minus probability of A, which is 1 minus 0.02, which is 0.98. And that is the probability of being non-diabetic. Complementary events are always mutually exclusive events, but mutually exclusive events are not always complementary events. Thank you.